Hello and welcome to the course Hacking and Securing JSON Web Tokens. In this video, I'm going to explain what you can expect from this course. This course basically consists of 4 different modules: Introduction, JWT In-Depth, and JWT Command Line Kung Fu, and finally Attacks and Defenses. In the first module, which is Introduction, we are going to see a very basic introduction to JWT or JSON Web Tokens. And we are also going to see how the lab setup for this course looks like. After that, we are going to see JWT In-Depth. In this module, we are going to discuss how JSON Web Tokens are created and validated. This module is going to be a deep dive of JWT. We are going to see various cryptographic algorithms that are commonly used in creating and validating JSON Web Tokens. And the next module, JWT Command Line Kung Fu, is a follow-up to the second module, which is JWT In-Depth. In the second module, we are going to get the theoretical knowledge of JWT. And in the third module, we are going to practically create JSON Web Tokens using pre-existing command line tools. We will use command line to create JSON Web Tokens using algorithms like HS256 and RS256. That's an interesting module. By the time you complete the third module, you will have a solid understanding of JWT. The last module is Attacks and Defenses. This is where we are going to discuss some commonly seen JWT misconfigurations or insecure implementations. JWT is cryptographically safe. However, the one who is implementing JWT in his applications may make mistakes, and that's exactly what we are going to see in this module. So this module, Attacks and Defenses, is helpful for both developers as well as security professionals. You can be a pen tester who is testing an API which is using JWT token, and you want to find out the possible vulnerabilities in the API. And that's what exactly is going to be discussed in this module. After discussing the possible attacks, we are also going to see the defenses that we can use to prevent such attacks. Alright, that's all we have in this course. If this is of your interest, click that enroll button and see you in the course. Once again, welcome to the course Hacking and Securing JSON Web Tokens. And let's begin with the module Introduction. In this video, we are going to get started with understanding the lab setup we have for this course. I have created 3 different JWT implementations, and all of them are included in this Secure Store VM. We will explore this virtual machine later in this course, but for now, download this VM and import it into VirtualBox. So the first step is to install VirtualBox and then import Secure Store VM into your VirtualBox. Followed by download and install Kali Linux as one of the virtual machines in VirtualBox. After that, we need to have Postman Chrome extension. All of these installations are very straightforward, and let me quickly show you how the setup looks like on my machine. Let me switch to VirtualBox and log into Kali Linux VM. I am logging into my Kali machine. All we are going to use in this Kali machine are browser and a terminal. We don't have to install any external tools into Kali because we are going to use simple tools like OpenSSL and SED, which are already installed in your Kali machine. So all we need is a browser and a terminal. So that's all you need in Kali Linux. Now let me show you the other VM, which is Secure Store. This is how it looks like. This is Secure Store JWT VM. The username is Secure Store and the password is Secure Store, and these credentials will be available in the download link. The IP address of this machine in this case is 192.168.1.79. So let me log in over SSH. SSH is already enabled in the VM. You don't have to enable it. 1.79 and Secure Store. Now let me just type ifconfig and you are inside Secure Store VM. So this is the setup that we are going to need. We are going to log in from Kali Linux machine into Secure Store server over SSH. Right, so that's done. Now the only tool that we are left with is Postman. Postman is a client which is commonly used for accessing REST APIs. I have installed Postman that comes as a Windows application. This can be downloaded from here. www.postman.com/downloads. You can download this Postman from here. I have already done that. It looks like this. Let's click on this Postman application and it should launch Postman for us. We're going to see how to use this Postman later in this course, but for now, make sure that you have this set up in your machine. Let me reiterate. We need to have VirtualBox with Kali Linux installed. Remember, Kali Linux is going to be an optional tool because we are only going to use OpenSSL and sed from Kali Linux. So you can use any other Linux distribution if you already have one. Now, Secure Store VM, this is given for download. So just download it and import it into your VirtualBox. And finally, we need to have Postman Chrome extension or a desktop application. In my case, I'm using the desktop version of Postman. Alright, that's all with the lab setup. In the next video, we are going to get started with Introduction to JWT. Let's understand what a JSON Web Token is. JSON Web Token is an open standard which is defined in RFC 7519, and it defines a compact and self-contained way for securely transmitting information between parties as a JSON object. This may sound complicated. Now let's try to simplify this. In simple words, JSON Web Token is a standardized format that is used to securely transfer information between two parties. Now, when I say securely transfer information between two parties, it doesn't mean that a JSON Web Token can have confidential information. What it means is you can use JSON Web Token to identify the person who is requesting for specific information is authorized to access the information or not. We also mentioned that JSON Web Tokens are used to transfer information between two parties. So these are the two key properties of a JSON Web Token. 1. Exchange information. 2. Ensure that the information which is exchanged between two authorized parties. So that's a JSON Web Token. Now, it's fine if it is still unclear about how JSON Web Tokens are used and what they are used for. Trust me, by the end of the course, you will be able to practically understand everything about JSON Web Tokens. Now, this is the structure of a JWT. A JWT contains a header followed by a dot, followed by payload, followed by dot, and then followed by signature. So essentially, a JSON Web Token contains three parts separated by two dots. While this is the structure of a JSON Web Token, let me show you an actual JSON Web Token. This is how it looks like. If you look at this, the first part is a header in blue, followed by a dot, followed by a payload, followed by another dot, followed by a signature. As I mentioned, this JSON Web Token has three parts: header, payload, and signature. They are separated by dots. Now, if you are wondering what kind of encryption or encoding that's used to produce this particular token, let me clear that. If you see this, the first two parts, which are header and payload, can be converted into clear text because these two sections are simply base64 URL encoded. We will get into what base64 URL encoding is in a moment, but for now, let's remember that header is base64 URL encoded, so you can simply do a base64 URL decode to get the clear text header. And similarly, payload is base64 URL encoded. You can simply do a base64 URL decode to get the clear text version of this payload. As I mentioned, these two parts are base64 URL encoded. Now, what is base64 URL encoding? You might have heard about base64. Base64 is commonly used for encoding text transferred over the network. Now, characters that are used in base64 encoding sometimes may cause problems when the base64 encoded data is transferred over the network, especially through the GET parameters and HTTP headers. This base64 URL encoding solves that problem. It's a variant of base64 encoding, but with few minor differences. Those differences are: in base64, you will see plus. In base64 URL, the plus is basically replaced with minus. Similarly, slash is replaced with underscore, And it is very common to see a padding character like this in base64 encoding. You won't see this padding character in base64 URL encoding because these padding characters are omitted. So these are the only differences that you see between base64 encoding and base64 URL encoding. Now you get the point. If you go back, you won't see any padding, or you won't see any plus, or you won't see any slash in any of these. The reason is base64 URL encoding. If you see this signature part, here there is a minus. If base64 encoding was used, instead of this minus, you would see a plus. Similarly, there is an underscore here. If it is a traditional base64 encoded string, you would see a slash instead of underscore here. So that's the basic difference between base64 encoding and base64 URL encoding. Okay, now we are clear with how the header and payload are encoded. But if you see the third part, which is the signature, we didn't decode it. There is a reason. This string is not simply generated by using base64 URL encoding on a specific clear text string. There is much more than that. We are going to see the details of this signature, including what kind of cryptographic algorithms are used and how this is produced and all that in the next module. But for now, just remember that this signature is generated using some cryptographic algorithms such as HS256 and RS256. Specifically, the signature that is on the slide is created using HS256 algorithm. I know it may sound complex now, that's why let's not get into cryptography stuff right now. First, let's understand a few more details about JSON Web Tokens before we get into crypto details used in these signatures. Now, let's understand how JSON Web Token works. Let's assume that we have a client who wants to retrieve some information from this resource server. This is also commonly known as API server. But the resource server wants to ensure that the client is authorized to retrieve those details that he is requesting for. First, the client contacts the authorization server with his login credentials. Now, some people call it authentication server as well, but I prefer to call it authorization server because even though authentication is performed on this server, the main purpose of this server is to provide an authorization token. So I call it authorization server. Once the client provides the login credentials to authorization server, it traditionally talks to a database in which the credentials are stored, and authentication is performed using a programming language like PHP. In our labs, we are going to use PHP everywhere. So we write a PHP program to authenticate this particular user by verifying the credentials in the database. Once the client is authenticated, then a JWT token is going to be generated. And that's when this authorization server replies back to the client with a JWT token in the response. Now, this client presents this JWT token to access the resource that he wants from the resource server 1. Now, I call this resource server 1 because the same JWT token can be presented to multiple servers as long as all these three servers are having the same verification token that's associated with the token on the authorization server. So let's go back to the third step. Once this client presents the JWT token to the resource server tries to verify if the JWT token is valid or not. Essentially, this resource server verifies the integrity of the token. It wants to ensure that the client who is sending the token did not tamper the values present in the header and payload in any way. So once that validation is done, the client will be presented with the resources that he is requesting for. As I mentioned earlier, the same token can be presented to multiple different APIs. As long as they can validate this token, they will be happy to respond with whatever the resources that this client is trying to access. Now, if an attacker tries to access any of these resources, he won't be able to get access to those resources because he doesn't have a valid JWT token. To be able to successfully access these resources, which are given back only with a valid JWT token, the attacker either needs to have login credentials so that he can request the authorization server for a valid JWT token, or he needs to have the signing key which is used to produce this JWT token. So there are two options for him: compromise the client's credentials and request authorization server for a valid JWT token. That's option 1. Option 2 is the signing key is available on authorization server, and depending on the type of algorithm used, the signing key may also be available on the resource servers. We will get into the details of algorithms later, but for now remember, it's possible that the signing key can be available on the authorization server or on the resource server. So he needs to compromise one of these servers to be able to get this signing key, so he can create his own JWT tokens and request these resource servers to give him access to those resources. This is how JWT works. If all this process looks so complex, let's try to understand this using the lab we have. So now let me show you a demo of how this process works using our lab. You can also follow this demo if you have installed Postman as well as Secure Store Server. Now let's see a demo of how JWT works. I'm switching to my Postman client. This is how the Postman client looks like. Now, to be able to interact with the Secure Store APIs, we need to have some sort of documentation. So I have created some basic documentation of the APIs we have on Secure Store Server. This API documentation should be available for download, and this is how it looks like. It contains a brief description of the APIs we have. As you can see in the description, this project has been developed for registered customers to request their respective credit card numbers. So one can request for the credit card numbers. Now for that, a user can log in and request for a credit card number to be displayed. However, there is a security requirement that credit card numbers should not be displayed if the incoming requests are tampered in any way. For this reason, JSON Web Tokens are used to implement authorization. Okay, this is pretty clear. Using these APIs, we can access credit card information, but for that, you need to be an authorized user. So you need to authenticate using a username and password. After that, you need to present a JWT to retrieve the credit card number. There are 3 versions of API endpoints available with the exact same functionality, but with different JWT implementations. Now you might be wondering why we need different JWT implementations. You will get to that later in the course, but for now we want to understand how JWT works. You can use any of these 3 different API endpoints to retrieve the credit card numbers, but for now just use V2 or V3 because V1 gives you a slightly different type of JSON Web Token. You will understand why in later videos, but for now let's just go with V2 or V3. Now for that, obviously we need to have some username and password. So I have provided 2 sets of usernames and passwords. This is one set and this is another set. For now, we are going to use this set of credentials. Okay, how to invoke these APIs? As you can see, first one is the login request. We can use V3 or V2 endpoint, and we need to use post method. And there is a mandatory header, which is content type application/JSON. So this has to be used when making the login request. Now let's make this login request using Postman client and see how it looks like. I'm just copying this sample post data. Now let's switch to our Postman client. As we have seen in the documentation, the login request should be using post method. So let's change it to post. And my authorization server or authentication server is available at 192.168.1.79/v2, and the body is going to be raw body, which looks like this. And apart from that, I need to have a header, which is content type application/JSON. Okay, now let's go back to the body and let's click send. There you go. As you can see this, the authorization server has sent a response with a JSON Web Token. So this is the JSON Web Token that we have been talking about. This is how it looks like. The authorization server has provided us with a JSON Web Token because our username and password are valid. Okay, now let's copy this and go back to the documentation. Now we need to make a request to a resource server. In this case, the authorization server as well as resource server are available on the same IP address. Instead of having them on two different machines, I have set up everything into one virtual machine, so it's easier for you to do the labs. So what it means in our architecture is this authorization server has given us a token. Now the client has received a token. Now we are here with a valid JSON Web Token. Now we need to request for a resource from the resource server. What I'm trying to say is we don't have a separate resource server in this lab. The resource server is also the authorization server. So basically with the JSON Web Token, you're going to make a request to authorization server. Since you are passing a JSON Web Token, now this server acts as a resource server. I have done this just to avoid multiple different servers in your lab. So I have set up only one server with all the features included inside it. Now this is the part of documentation which shows us how we can retrieve the credit card information using the JSON Web Token that we have gotten. Once again, this is a post request and these are the mandatory headers. And here is a sample HTTP request for us. We need to have post and the JWT token has to be passed like this with the word bearer using authorization header. And also we need to pass this JSON body so the resource server knows that you are requesting for credit card information. Alright, so let's go back to the Postman client and let's add an authorization header. And let's add a value bearer space paste the token that we have received from the authorization server. Okay. And now we need to change the body slightly. You can actually remove all these credentials here. They are not needed anymore. And change the word login to get CC info. Alright, that's all. Now we can hit the send button and see if we get the credit card information associated with the user secure store. There you go. So as you can see, we have received the credit card number for the user secure store. Now, if you tamper this JSON Web Token in any way, it's not possible for us to retrieve this credit card information. Let's try that. I'm going to change this JSON Web Token slightly. Let's probably remove 1 or 2 characters. And let's click this send button. And look at that. Signature verification failed. And you can't get the credit card information anymore. So this is how JSON Web Tokens work. You pass your credentials and obtain a JSON Web Token and present this JSON Web Token to another resource server to get access to some resource. In this case, credit card information is what you are trying to access. Right. I hope this has made it clear about how JSON Web Tokens look like and how they work. In the next module, we are going to see some more details of how the resource server is able to recognize this user secure store and why it is unable to verify the signature when the token is slightly changed. Let's summarize this module. We understood that JSON Web Tokens are made of 3 parts: header, payload, and signature. Header and payload are just plain JSON objects, and they are encoded using base64 URL encoding. And we also understood that signature, which is the 3rd part, is used to validate the payload on the resource server. Header and payload are not encrypted. Anyone can see what's inside the token because they are just encoded using base64 URL encoding. So it is important that we do not include any sensitive information in the payload. Welcome to the second module, JWT in depth. As the title says, this module is going to give you deeper understanding of JSON Web Tokens. So let's get started. The first part of any JSON Web Token is headers. This JWT header is extracted from the sample token that we have been seeing in the first module. This header contains 2 parts. It says that the type of the token is JWT and the algorithm used is HS256. It basically contains some metadata about your JSON Web Token so that the resource server knows what kind of encryption should be used while validating the signature. So essentially, this information is essential for the resource server to be able to validate the signature. After reading the type of algorithm from this header, the resource server will use the same algorithm to verify the signature before providing access to the requested resource. That's JWT headers. the key information in headers is the type of algorithm used. Now let's understand the payload section of a JSON Web Token. Once again, this section is extracted from the same token that we have been using. Now, if you look at this, the payload section typically contains some user identification information. If you notice this, there is a key value pair which says the user ID is secure store. This is the username, and it also says whether this user is an administrator or not. Since isAdmin is set to false, this user is not an administrator. So what it essentially means is once the signature part, which is followed by this payload part, is verified to be valid, this user secure store will have access to the resources that he is requesting for. While JWT payload usually contains user identification information, you may also see some other supporting properties like this: IAT, ISS, EXP, to name few. IAT represents the timestamp of the creation of this JWT, which is usually in seconds since epoch. And then the next one is the issuing entity. In this case, our authorization server is what has issued this JWT. In this case, the word localhost is used, but it's up to the developer, and he can basically place anything that represents the authorization server. And the next one is expiry. This represents the token's expiration timestamp. Once again, this is in seconds since epoch. So to summarize, a JWT payload contains user identification information along with some supporting properties such as IAT, ISS, and expiry. Now let's understand the next part of our JSON Web Token, which is signature. This is the last part. Now the sample signature that is shown on the slide is HS256 signature, but you may also see longer tokens which are created using RS256 algorithm. This signature part is what is crucial to ensure that the JWT tokens are not tampered with. Typically, the key elements that are involved in creating the signature are header, the payload, and a key which is used with the algorithm, and finally the type of algorithm that you want to use to create the signature. Once the signature is created using these elements such as header, payload, and the key, the signature will be appended to the header and payload. When the JSON Web Token is sent to a resource server, this signature will be extracted and the signature is recalculated on the resource server to make sure that the JWT payload is not tampered in any way. And as I mentioned, HS256 and RS256 are two most commonly used algorithms when creating JSON Web Tokens. Now let's get into the details of how these two algorithms work. Let's understand how HS256 is used in creating and validating JSON Web Tokens. HS256 uses SHA-256 HMAC, which is hash-based message authentication code. So what this means is HS256 algorithm takes the base64 encoded header followed by a dot and the base64 encoded payload as the input, and then it doesn't simply produce a SHA-256 hash of these two, because it's possible for anyone to get this header and then append the payload and then create a SHA-256 hash of it. But the main idea behind JSON Web Token is that nobody should be able to tamper with the payload. They shouldn't be able to create their own signature. So when we use HS256 algorithm, a separate secret is going to be appended to this header and payload, and this secret is only known to the authorization server and resource server. An attacker cannot simply add his own secret to this header and payload and then create signature. If he does that with his own secret, the resource server will not be able to validate the JSON Web Token and the authorization fails. So one can reproduce this hash only if he has the secret. So to summarize, HS256 algorithm takes the base64 encoded version of this header followed by a dot and the base64 encoded payload, and it appends a secret which is only known to the authorization server and the resource server, and then it performs a SHA-256 hash of that. And once again, it's going to be encoded using base64 URL encoding algorithm, and then it's going to be appended to the header and payload. And that's how you have gotten this particular signature using HS256 algorithm. Now let's see a visual representation of this so you can better understand what's really going on when you are using HS256 algorithm. As usual, first the client needs to authenticate with authorization server. So he sends his login credentials, and this authorization server first verifies if these credentials are valid. If these credentials are valid, a secret key is used to generate a JSON Web Token. This secret key also needs to be distributed to all the resource servers. When the client presents this JSON Web Token to the resource server, this resource server will be able to validate this JSON Web Token only if it has this exact same key. This is the case with HS256. The resource server as well as the authorization server should have the exact same key. The authorization server uses this key to create the JSON Web Token, and the resource server uses this key to validate if the JSON Web Token is actually created by someone who has this key, which is authorization server in this case. Right, so once that is done, the client will actually get access to the resources that he is requesting for. Now, once again, if an attacker tries to access this particular resource, which is the credit card number in this case, he won't be able to do that because the resource server checks for a valid JSON Web Token. Now, if the attacker wants to get access to these resources, he either needs to have login credentials so that he can get a valid token from the authorization server, or he needs to have access to this shared key. How can he get this shared key? There could be multiple possibilities. 1, the authorization server is compromised. 2, the resource server is compromised. 3, the key is insecurely distributed. So when the key is distributed, somehow the attacker gets access to it so he can create his own JSON Web Tokens. So these are all various possibilities to get this secret key. So if the secret key is somehow accidentally leaked, and if the attacker gets access to it, it's possible that an attacker can tamper with the JSON payload and he can create his own JSON Web Token to access the resources. So here are some of the potential security issues when HS256 algorithm is used to create a JSON Web Token. Key must be distributed to all the servers. So when the key is being distributed, it's possible that an attacker can steal the key, or if the key is insecurely distributed, it's possible that an attacker can get access to it. Now, if one server is compromised, the shared key can be stolen. Since we are using the same key on all the resource servers as well as on the authorization server, it's possible that if one of these servers is compromised, the key will be stolen. And the last possibility is, if the secret key that is being used by HS256 is weak, it is possible that the secret key is brute forced. We will see a demo of how this secret key can be brute forced in the attacks and defenses module of this course. For now, just understand that these are the possible security issues associated with HS256. Now that we have seen how HS256 algorithm works, let's see a demo of one of the APIs that's available in our lab, which is developed using HS256 algorithm to create a JSON Web Token. I'm switching to my Postman client, and I'm going to invoke this API that's available on /v2. Like we did earlier, I'm going to copy the login post details from the API documentation file. So let me just copy that. And let's paste it here. And now let's click on this send button. If you see, we have gotten a JSON Web Token, and this is generated using HS256 algorithm. Now let's get into a virtual machine and take a look at the source code associated with this particular endpoint available at /v2 in the web root. So I am logging into my Kali machine, and I have already logged into my secure store VM. Now let's navigate to where www HTML v2. Here we have a bunch of files, And API.php is the file in which we have the source code associated with the endpoints, login and get CC info. Now let's open API.php using Vim and let's scroll down. And if you see, this is the code associated with the login function. And inside this, we have the authentication code first. We are receiving the username and password from the client, and then we are verifying these user credentials against a database. And once if the user is found to be valid, we are creating a payload. And if you see, this payload contains issued at and the issuer and the expiration time and the user ID. In this case, if you log in as secure store, this will be replaced with secure store, and is admin, in this case it's false. And this is the payload that we have seen earlier in our JSON Web Token. Now if you scroll down, we are invoking the encode function from a library, and we are passing it HS256 as the algorithm to be used to encode this particular payload. And if you scroll up, this HS256 algorithm is using a secret key along with it. So whenever a payload is passed to HS256 algorithm, it's going to use a secret key to produce a signature. This particular secret key is defined in a file called constants.php. If you see this particular API extends REST, which is basically available in rest.php. That's a class available in rest.php. You can see this here. And this is loading constants.php. So if you take a look at the file constants.php, and if you look for secret, you should see there is a secret key available here. So this secret key is being used with HS256 to produce a signature for us. Right? Now, if you go back to this API.php file and scroll down, the token is created and it is sent to the client. And when the client requests for get CC info, we are receiving the token, and then we are actually checking if the token is valid or not. So this validate token basically receives the token and validates it. So let's go back to rest.php, inside which we have the function validate token. Let's scroll down. Okay, if you look at this, it's basically calling another function called getBearer token, which basically gets the token from the authorization header, and then the token is being passed to this JWT decode function. And when the decode function is called, there are two important parameters that are being passed to this decode function. One of them is the token that's sent from the client, and the other one is an array of algorithms. So let's go back to the API.php and see what these algorithms are. If you look at this, these algorithms are basically an array which contains two different algorithms. One is none and the other one is HS256. Since the JSON Web Token payload contains the word HS256 in algorithm section, this HS256 algorithm is going to be used to verify the signature. Once the verification is done, the credit card information will be retrieved from the database. You can see this here. First, validate token function is called, and it is returning a valid username. And then we are running a simple SQL query to basically retrieve the credit card information associated with this user. And once the credit card information is retrieved from the database, we are sending that information back to the client as JSON response. So this is how HS256 algorithm is used when creating a JSON Web Token as well as when verifying the signature. Let's switch back to the presentation and let's summarize HS256. When HS256 algorithm is used, a shared key is used both for creating the signature as well as validating the signature. If this key is stolen, anyone who has access to this key can create a valid JSON Web Token. In this case, the authorization server can create a JSON Web Token as well as the resource server can also create a JSON Web Token, because it is a shared key to both create a valid token as well as to verify the token. We also discussed that if a weak key is used, it is possible that we can brute force it. And another key point that we have learned is SHA-256 is applied on header, payload, and the secret to produce a digital signature. This is all about HS-256 used for creating and validating JSON Web Tokens. In this video, let's discuss how RS-256 algorithm is used in creating and verifying JSON Web Tokens. RS-256 behind the scenes uses RSA algorithm and SHA-256 hashing algorithm. First, the header and the payload are taken out, and a SHA-256 hash of the header and payload is created. Once that is done, the hash is digitally signed using RSA private key. So essentially, RS-256 signature is a signed SHA-256 hash of header and payload. That's what forms a digital signature, which is the third part of a JWT token. Once the authentication server creates a digital signature and produces a JSON Web Token, this token is given back to a client. When the client presents this JSON Web Token to a resource server, the resource server requires RSA public key to validate the signature. The resource server ensures that the signature that's present in the JSON Web Token is actually created using the private key that's part of the public-private key pair. Now, if an attacker wants to create this JSON Web Token using RS-256, he needs to have access to the private key that's available only on authorization server. What it also means is, even the resource server cannot create a JSON Web Token. It can only validate if the JSON Web Token that is created by authorization server is valid or not. If you are new to crypto and if this sounds complex, don't worry. In the next module, we are going to create HS-256 and RS-256 signatures manually using some command line tools. That lab exercise makes it clear about how HS-256 and RS-256 algorithms are used to create the signatures which are part of the JSON Web Tokens. Now, to give you a better understanding of this RS-256, I have also created some visuals to show you RS-256 in action. Let's see how it looks like. Once again, let's assume that the client wants to get access to some resources from this resource server. Now, the client first needs to get a JSON Web Token from the authorization server. For that, it needs to get authenticated first. So the first step is to present the login credentials to the authorization server. So the client presents the login credentials, and on the authorization server, the authentication is done by using the traditional means. In this case, a SQL query is used to verify these credentials in the database. Once this user is identified to be authenticated, this authorization server makes use of an RSA private key to create a JSON Web Token. Once this JSON Web Token is created, this authorization server responds back to the client with the token. Now, after the client receives this JSON Web Token from the authorization server, it presents this JWT to the resource server. Now, the resource server needs to validate if the signature present in the token is valid or not. So it uses the public key, which is publicly available with all the resource servers, to verify the signature that's present in the JSON Web Token is valid or not. Once again, if an attacker tries to access these resources, the access will be denied because the attacker doesn't have a valid JSON Web Token. For the attacker to successfully access these resources, either he needs to have valid login credentials so he can present them to authorization server and then get a valid JSON Web Token that he can present to the resource server. Another option is that he needs to get access to the private key, which is available only on the authorization server. He needs to somehow compromise the authorization server and get access to the private key so that he can create his own JSON Web Token. If you remember, when we were discussing HS-256, we noticed a disadvantage, which is the private key is being shared across the resource servers. So if one resource server is compromised, an attacker can simply get access to the private key from any of those compromised resource servers, and he can create his own JSON Web Tokens. In this case, with RS-256, even if the resource servers are compromised, the attacker will not be able to create his own JSON Web Tokens because all the resource servers only contain the public key, which is anyway public, and this public key can only be used to verify the tokens but not to create the tokens. So once again, here is a list of benefits with RS-256. The first one, the private key is known only to the authorization server. And the next one is only the server with private key can create a new token, and the servers with the public key can only validate the token that's generated by authorization server. And the third one, prevention of brute force attacks. If you remember, when we were discussing about HS-256, I mentioned that it is possible to brute force HS-256 keys if they are weak. In case of RS-256, it is highly unlikely that brute force attacks work against these keys because RSA keys are long enough to prevent brute force attacks. In the next module, we are going to create RSA keys and you will see why they are difficult to brute force. Alright, that's all I have in my mind for this video. In the next video, we are going to see a demo of RS-256 based JWT implementation. Now let's see a demo of RS-256 based JWT implementation. First, let's switch to our documentation and see the available list of APIs. As you can see, there are three different API endpoints here. V1 is something that we will discuss in the next video. V2 is what we have seen with HS-256. So basically, if you are interacting with this API, you are going to get a JSON Web Token that's created using HS-256. Now we are discussing about RS-256, and this endpoint is what implements RS-256 based JSON Web Tokens. So let's switch to our Postman client and try to log into this API using the credentials that we have, and let's try to get a JSON Web Token followed by taking a look at the source code. Here is my Postman client. I am launching it. We need to interact with /v3 from the secure store JWT server. So I'm accessing the IP address /v3, and the request method should be post, and it needs to have the content type header to be set with the value application/JSON, and the body should contain the username and password and the action that we want to perform. In this case, we want to log in so that we can get a JSON Web Token. So we are specifying the action as login. Now let's click this send button, and there you go. We have gotten a JSON Web Token in response. So let's copy this and paste it in Notepad. And if you look at this, the signature part of this JSON Web Token is relatively longer than what you have seen with HS-256. This is one hint that HS-256 is not used to create this signature. Now let's log into our secure store server from Kali Linux and explore the source code associated with this implementation. I'm logging in to my Kali Linux. Now let's log in to secure store server using SSH. There you go, we have logged in. Now let's navigate to var www.html/v3. Now here we should see a file called api.php and rest.php. We are going to use these two files to explore the implementation. I am going to use Vim to read the source code of api.php. Let's take a look at the function login. Like we saw with RS-256, first, the username and password are taken from the client, and then a standard authentication is performed using some SQL queries. And once the user is authenticated, a payload is created, and then the payload is given to this function encode along with the private key along with the name of the algorithm to create this JSON Web Token. In this case, we are using RS-256 to create this particular token, and a private key is used to produce the signature. Once this is done, we will get a JSON Web Token which is created using RS-256. After this is done, when the user tries to present this token to a resource server, the resource server essentially validates the token using the public key. So let's take a look at how that is implemented by taking a look at rest.php file. I'm using Vim to read the source code of this rest.php and scroll down and let's take a look at the function validate token. If you see this, first the token is extracted from the HTTP request. After that, the decode function is called with a public key. Here, an array of algorithms is passed, but that's okay. In this case, you have seen that the token is created using RS-256. So RS-256 is going to be chosen to validate the signature. On a side note, this implementation is insecure. We will see how to exploit this in the last module, where we are going to discuss attacks against JSON Web Tokens. But for now, let's remember that when validating the token, we are using RS-256 along with the RSA public key. Right, I hope this makes it clear, but one last thing that I want to show you before I end this video, that is the contents of the private key and public key. Because these are variables, you don't really know if I'm really using a private key to create a token and a public key to verify the token. So let me quickly show you the values of these two constants, private key and public key. I'm closing the file. Let me quickly show you the contents of the file constants.php. And if you look at this, the constant public underscore key is defined here, and it is using a public key which is generated using OpenSSL command line client. And the constant private key contains the actual RSA private key, and this is also generated using OpenSSL command line client. Alright, I hope now it is clear that we are using a private key to create a JWT signature, and we are verifying that using a public key. In this video, let's discuss none type signature. While this none type signature is not commonly seen when creating JSON Web Tokens, there are some JWT frameworks which provide support for this signature. And because of this support provided by the frameworks, there could be some insecure implementations of JWT leading to attacks like signature stripping. We will see a practical demo of signature stripping attack in the last module of this course, but let's now understand how this none signature works. None signature means there is no signature at all. And this is how the JSON Web Token that is created using none signature looks like. So you will essentially have only the header and the payload. There is no signature appended to it. The signature is empty. If at all a JSON Web Token is created using none type signature, it is possible for the client to tamper the data and send the tampered data to the server, and the resource server will not be able to know if the payload is modified, because there is no signature associated with this token, and it is not possible for the resource server to verify if the token is modified. Let's see a quick demo of how this none signature works using our lab setup. I'm switching to Postman. I'm changing this V3 to V1. And once again, I am logging in using my username and password. And let me click send. And we have gotten a token. Now let me copy this and paste it in Notepad. And if you see this token, here are the JWT headers followed by a dot. And here is the JWT payload followed by a dot, and the signature part is empty. Now we can simply base64 URL decode these headers and the payload, and we can change it as we want, and base64 URL encode it back, and we can use the tampered token to access the resources from the resource server. We will see that attack practically in the last module once again. I'm going to demonstrate all the possible attacks against JSON Web Tokens in the last module. But before we get into the last module, let's make sure that we are clear with the JWT concepts. That's all I have in my mind for this video. See you in the next one. Hello and welcome to the module JWT Command Line Kung Fu. This module is going to be very interesting because we are going to use some existing command line tools to actually produce HS256 and RS256 signatures. So let's get started. As I mentioned, we are going to see how to create HS256 signature using command line, followed by we will see how to use OpenSSL to create public and private key pairs, and after that we will also see how to create the signature using RS256 algorithm. Now in this video, let's take a look at how the first one is done. we are going to see how to generate HS256 signature using command line. Let me switch to my Kali machine. Before we get into creating a HS256 signature using the command line, I would like to show you a page that I have created. This is accessible on your secure store server on /v3/hs256.php. Try to access this and it will produce a sample HS256 JSON Web Token for us. The token that's displayed here is created using a JWT framework. However, we are going to reproduce the exact same token using command line. To do this, we need to know two important points. One, the basics of HS256. Number two, the tools that we need. We can use OpenSSL and SED, which are already available in Kali Linux. And the first part is understanding HS256. We have already gone through the basics of how HS256 works. If you haven't watched those videos, it is highly recommended that you understand how HS256 works before following this video. So let's begin. First, let's take a look at the token. It contains three parts. One, the JWT headers. Number two, the JWT payload. And the last part is the signature. And this signature is created using HS256 algorithm, and the shared key that is used to create the signature is 123456. Now we want to be able to create this particular signature using the details available here. So this is the input for us, and this is the algorithm that we want to use, and this is the shared key for HS256. So let's first copy this and open up a terminal, type echo -n, and let's paste the base64 URL encoded version of the headers and the payload. So I'm pasting it here. This is what we have obtained from the page that is available in Secure Store Server. Now notice that there is no dot at the end. We have removed it. Now let's pipe this into OpenSSL. So OpenSSL will take this as input, and we want to produce a SHA-256 digest of this first. So SHA-256 digest can be created using the option dgst space -SHA-256, and this hash is created using a secret token to produce a hash-based message authentication code. So let's type hmac space the secret code 123456. We are using a binary format, and let's pipe this output to OpenSSL base64 because we want to convert the signature into the base64 URL encoded version. However, OpenSSL doesn't support base64 URL encoding, so we are first encoding it using base64, and we will pass this base64 encoded string to SED to replace plus with minus and slash with underscore. So let's first use base64 from OpenSSL, and then let's pipe that output to SED. So we are using -e to specify that we need to encode it, and -a so that the whole output is going to be treated as a string in one line. Now let's use SED with a simple regex to replace plus with minus. And I'm specifying G, so all the occurrences will be replaced with minus. And once again, the output will be passed to SED to replace slash with underscore. So SED, I missed S before, S slash slash, and we need to specify the slash here, and we need to replace it with underscore, and finally /G. And finally, let's pass this to SED once again to actually omit the padding characters. -e stands for extended regular expression. So let's just use this. Okay, this command should produce the signature that we are looking for. So let's hit enter. There seems to be a problem here, unknown option to yes. So let's put it in single quotes. and hit enter, and there you go. If you see this, the signature is starting with KXGL. Let's go back and check what we have gotten in the web page. If you look at this, this is exactly the same, KXGLQW. There you go. And it ends with DVTC. So this is how we can use command line tools like OpenSSL and SED to produce HS256 signatures. That's all for this video. In the next video, we are going to see how to create a public-private key pair using OpenSSL. Welcome back to another video. In this video, let's see how we can use OpenSSL to create RSA public and private key pairs. In the next video, we are going to see how to create RS256 signature. And that exercise requires access to a private key. Even though we are not going to use the private key that we are generating now, it is important for us to understand how these keys are actually generated and being used by the authorization server. So let's get into the Kali machine and create a public-private key pair using OpenSSL. I am switching to my virtual machine. Now I am on a new terminal. Now let's first create a new directory called RSA keys because it is going to produce two different files for us. So let's store them in a folder called RSA keys. So I have navigated to RSA keys directory. Now let's type OpenSSL gen RSA out private.pem and let's specify 2048. Hit enter. As you can see, an RSA private key has been generated with 2048-bit long modulus. Now, if you check the current directory, it should have a new file called private.pem. Now let's use this private key and produce a public key. To do this, type OpenSSL RSA -in and private.pem -out public.pem space pub out and out form is pem. Hit enter. Now let's type ls. If you notice, there is another file called public.pem. Now let's clear the screen and let's take a look at the contents of private.pem. And if you see, this is an RSA private key. Let's also take a look at the contents of public.pem. And if you see, this is a public key. If you remember, we discussed about RS256 algorithm. RS256 algorithm uses the private key that we have seen earlier to create the digital signature, and this public key will be used to verify the signature. So that's what we are going to see in the next video. We are going to create RS256 signature manually using command line. Welcome back once again. In this video, we are going to produce RS256 signature from command line. So once again, let's switch to our virtual machine. Like I did with HS256, I have also created another file called RS256, which is available within v3 directory. So let's try to access rs256.php and it will create a sample JSON Web Token for you using RS256 algorithm. So what we are going to do is we will once again take this token and we want to produce this signature using this private key. And we are going to use RS256 and we will use this base64 URL encoded version of the JWT headers and the JWT payload as the input. Okay, so let's get started. First, let's copy this private key because this is the key that is used to produce the signature. So we need it to be able to reproduce the exact same signature which is shown here. So let's copy this and save it in a file. I'm creating a new directory called rs256 and let's navigate to rs256 and let's create a file called private.key. Hit enter and let's paste the RSA private key here. I'm saving this file. Now let's go back to the browser and copy the first two parts, which are JWT headers and the payload. Let's copy this. Now let's type echo -n, and let's paste the base64 URL encoded version of the JWT headers and the payload, and let's pipe it to OpenSSL like we did with HS256, and we want to create a SHA-256 digest of this. So let's specify DGST space SHA-256 with a hyphen, and once the hash is created, let's sign it using the private key that we have obtained just now. So this looks like this: -sign space the private key file name. Now this will produce the signature. However, we want this to be in base64 URL encoded format. So let's pipe this to OpenSSL once again and use base64 encoding with -a flag, and then let's pipe it to sed like we did with HS256 to convert from base64 encoded string to a base64 URL encoded string. So I'm just writing a simple regular expression using sed. And let's also pipe it to sed once again. So this part replaces all the occurrences of plus with minus. So now the next part is to replace slashes with underscores. So let's write a simple regular expression once again. And let's pipe it to sed once again to strip off the padding. Alright, so now we are done with the command. If we hit enter, it should produce a new signature. So let's hit enter. There seems to be an error. This usually happens if the private key formatting is not correct. So let's do one thing. Let's first log into the secure store server and obtain the private key from there instead of copying it from here. It is exactly the same private key, but we are just copying it from the secure store server itself. So let's switch to our terminal. And let's do a cat of var www.html v3 private.pem. It's available there. Let's copy it and replace the private.key file from our rs256 directory. So I'm just removing the private.key file first, and then I'm creating a new file, private.key, hit enter and paste it here and save this. And once again, if you run this command, it should work fine. There you go. If you see this, it has produced a new signature for us. It starts with EQC underscore. Let's go back to our browser and see if it is the same. As you can see, it starts with EQC underscore and it ends with PS6QYQ. It ends with PS6QYQ. So we managed to create this RS256 signature manually using OpenSSL. Before we end this video, I just want to show you that the private key that is shown here and the private key that we have used are basically the same. If you look at this, MIIE is what it is starting with. And if you look at our contents, it's exactly the same. Just the formatting was different earlier, so it has failed. Alright, this is how we can use basic command line tools to produce JSON Web Tokens. I hope you have understood how JSON Web Tokens work and how they are created. In the next module, we are going to look at various insecure implementations of JSON Web Tokens and how one can abuse them. Hello and welcome to the module Attacks and Defenses from the course Hacking and Securing JSON Web Tokens. In this module, we are going to discuss various attacks that are possible against insecure implementations of JWT. Let's begin with a quick overview of the attacks that we are going to discuss in this module. The first one is use of none algorithm. If none algorithm is used to generate a JSON Web Token, as I mentioned earlier, it is possible for anyone to create a forged JWT token and submit it to a resource server. Because there is no signature available in the token and there is no way for the resource server to verify if the payload is tampered with. So that's the first attack. The next one is signature stripping. Some frameworks support none algorithm, and on the resource server, if it is specified to use either HS256 or none algorithm, and if the client forces the resource server to use none algorithm, it is possible that the authorization will succeed even with a tampered payload. We will see all these attacks practically, so it will be clear when you see the demos. The third one is cracking weak shared secrets. If you remember, we mentioned multiple times that HS256 uses a shared key, and it is possible to brute force those shared keys if they are weak. So that's the third one. And the last attack is commonly known as substitution attack. We will confuse the server to use one algorithm instead of another. You will see all these attacks practically in the next few videos. So make sure that you have the lab setup available with you so you can practice all these attacks along with me. Alright, let's begin with the first attack, which is use of none algorithm for signature. But it is supported by the spec, and thus it is commonly supported by many JWT frameworks. Though this is not common for us to encounter during security assessments, it is important to understand how this works. That's because this knowledge is going to be useful when performing other types of attacks such as signature stripping. So let's try to understand this attack first. So let's see how this attack works. Before we get into the attack, let's understand our goal. Currently, we are logging in as Secure Store using the credentials Secure Store and Secure Store. We are able to see the credit card number of the user Secure Store because we have the credentials. Now the goal is to obtain the credit card number of the user admin. Let's assume that we know that there is a user called admin existing in the database, and we want to tamper the JWT token to retrieve the credit card number of admin. So let's switch to the Postman client and let's log in using Secure Store user to obtain a token that is generated using none type signature. So for that, we need to access /v1. Right, so I'm clicking send here because I already have the post data that we need. I'm clicking send, and if you look at this, we have gotten a token that we can use to retrieve the credit card number of the user Secure Store. Now let me copy this and paste it in a notepad, and this is how it looks like. Now if you see, we only have the JWT headers and we do have the JWT payload. Now let's try to decode this using base64 URL decoding and see what we have. Now let's copy this payload and let's search for a base64 URL decoder online. And I'm going to use this base64url.com. So let's open this up and let's copy this payload and paste it here. We want the base64 URL encoded string to be converted to a plain text string. So I'm pasting it here. And if you see, this is the plain text string associated with this base64 URL encoded string, which is basically our payload. And if you look at this, the payload says that the user ID is Secure Store. And what we are interested in is the user administrator. So let's copy this and let's change the user ID to admin. And let's copy this once again and let's paste it here. And if you see, this is the modified base64 URL encoded string. I'm pasting it here, and I'm also going to copy this JWT headers and I'm pasting it here. But before we send this token to the resource server, let's just quickly double check what we have in this JWT headers. I'm pasting it here. As you can see, it says the algorithm is specified to be none. So which is fine, that's what we want. Now let's copy this new JWT and pass it to the resource server to get the credit card information. So I'm switching to my Postman and I'm changing the authorization header with this new value that we have just crafted, and the body should contain get cc info, and we can just remove this information. Alright, so now we have created a new token that's associated with the user administrator, and if we successfully get response, we should see the credit card number of the user admin. Let's click on this send button, and there you go. If you notice, the user admin's credit card number is being displayed here. So this is how none algorithm can be abused, because it doesn't perform any signature checks on the server side. So anybody can tamper the JSON Web Token and make changes to the payload in a way that they want. Welcome back to another video. In this video, we are going to see the exact same attack that we have discussed in the previous video, which is abusing the use of none type algorithm. However, we are going to use Burp Suite instead of using Postman client. So from here on, we are going to use Burp Suite for all our attacks instead of using Postman. The reason is it is very commonly used when performing penetration testing. So I want to cover Burp Suite as well to see how we can perform the same attack. So I'm downloading Burp Suite free edition. So let's do that. Let's search for Burp Suite. And let's click on this download Burp Suite community edition. And click on the download latest version. And what we are interested in is the Burp Suite community edition for 64-bit. If you want, you can also use it from Kali Linux, but I prefer to use it from my Windows machine. Okay, so Burp Suite is downloaded. I'm going to install it now. Clicking next, 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 and finish. Now let's open the Burp Suite Community Edition. This is how it looks like. Now let's click on this application and it should launch Burp Suite Community Edition for us. I'm creating a new temporary project and I'm clicking on Start Burp. So this should launch Burp Suite. I'm not going to show you all the features that are available in Burp. Rather, we are only interested in this repeater feature. However, let me just first increase the font size. That should look good. Yes, it is. Okay, so now we need to add a target here, which is 192.168.1.79, and the port is 80. This is our secure store server. Let's click OK, and we can just simply copy and paste the sample request from our API documentation. So let's go back to our API documentation. And let's copy this and let's paste it here, and let's give some space between the headers and the body, and let's change this v3 to v1, and let's click on send. As you can see, we have gotten a JSON Web Token. This is the token for the user secure store. We also created a new token for the user admin. So let's use that token and try to retrieve the credit card number of admin here. So I'm creating a new tab here, and let me go back to my API documentation, and let me just copy this sample request and paste it here, and let me just remove this bearer token, and let me grab the modified token from the previous video. This is the one. So let's copy this and let's paste it here, and let's also change this v3 to v1. And one last thing that we need to change is the post body. So let's paste it here, and let's remove this, and let's call it get cc info. Okay, so this looks good. Now if everything goes well, we should be able to see the credit card number of the user admin. So let's hit send. Once again, it is asking for the host name and the port number, so let's just give them. There you go. We have gotten the user admin's credit card number. This is how we can use Burp Suite instead of Postman client to perform the same attack. Welcome back to another video. In this video, we are going to discuss an attack called signature stripping. So once again, the goal is to see the administrator's credit card number. So let's switch to our Burp Suite and let's try to access the API/v2. I'm giving a right click and clicking on send to repeater. So we will have a new tab with the exact same content. And here I'm changing the endpoint from v1 to v2. And if I click send, I should get a new JSON Web Token, as you can see here. Now let's copy this, and I'm going to paste it in Notepad once again. And let me decode these headers and see what algorithm is used to produce this token. I'm using this base64url.com once again, and I'll paste it here. And if you see, the algorithm that is used here is HS256. So this particular token is created using HS256 algorithm. Now, once again, this particular token can be used to see the credit card number of the user's secure store. So let's check that. So let's replace this here and put it here, click send. Okay, that's fine. That's because we did not change this to v2. And now let's try once again. And there you go. So we have gotten the credit card number of secure store that is expected. But we want to modify this particular JSON Web Token to be able to get the credit card number of administrator. Let's see if we can do that. So this is the token we have gotten, and this is the header. Let's also copy the payload and try to decode it. Nice. So this is the payload. Let's copy this. And let's change this to admin. And let's copy this once again and encode it. And this is the base64 URL encoded payload. I'm just copying this and let me paste it here. And now what we will do is we will also change these headers like this. We will replace HS256 with none, and we will base64 URL encode this. Here it is. This is the encoded version. So this becomes the JWT headers. I'm separating these two with a dot. So essentially what we are doing is we are telling the server that, hey, none type algorithm is used to create this token. So now you verify this token using none type algorithm. Let's see if it works. I'm copying this. I'm switching to a Burp Suite. And let's replace this token with the token that we have just gotten. And let's click send and see what happens. Seems like there are wrong number of segments. Yes, that is because we missed a dot at the end. So let's add it here. And now let's click send once again. And look at that. Even though we did not provide the signature, by changing the algorithm type to none in the header, we managed to tamper the payload and still got access to this admin's credit card number. Now let's log into our secure store machine and try to understand why this is working. I'm switching to my virtual machine. And I have already logged in to secure store server. Let's navigate to /var www.html/v2 and let's take a look at the file api.php. And if you notice, this particular piece of code defined two different algorithms. One is none and the other one is HS256. And let's scroll down and see what's happening when we are logging in. When we are logging in, the JSON Web Token is created using HS256 algorithm specifically. But let's go and see what's happening when we are retrieving the credit card number. So this is getCCinfo function. The first line that's getting executed is validate token. This function is inside rest.php. So let's take a look at the code of rest.php. Here it is. If you look at this, it is decoding the token by specifying the token and an array of algorithms. If you remember, in api.php, we have two algorithms defined. One is none and the other one is HS256. So basically we are accepting any of these two algorithms. If the token contains a header specifying the algorithm as HS256, HS256 algorithm is going to be used to verify the signature. And if the token contains the algorithm type as none, there won't be any validation on the signature because none type doesn't need any signature. Here, the core problem is that while decoding this token, we are letting the user choose which algorithm he wants to use to decode this token. So that's the problem. We will see how we can fix this when discussing the defenses later in this course. Welcome to another video. In this video, we are going to discuss how we can crack weak shared secrets that are used in creating HS256 signatures. So let's switch to the virtual machine. We are going to use a tool called JWT Cracker to do this. The tool is available on their GitHub page. As you can see here, it's a simple HS256 JWT token brute force cracker. Now, installation is pretty straightforward. We can use npm install to install this tool. So let's quickly install this. As you can see, my JWT cracker is already installed. Now let's take a look at the usage. If you see this, we need to provide a complete HS256 token and the character set that is used to perform the brute force and the max length. This is the maximum length of the string that we want to crack, which is the shared key in this case. So let's see how we can use this to crack a HS256 key. We need to have a sample JWT token which is created using HS256. Once again, we can use this hs256.php file to generate a token. I have already generated a token using hs256.php here. So I'm just copying this. Now let's switch to the terminal. And let's type JWT cracker. Let's paste the token and let's specify the character set 012 34 56 7 8 9. These are the only characters that I want to use, and the maximum length that I want is 6. Let's hit enter and see how long it takes to crack our secret key. As you can see, it took approximately 7 seconds to crack this secret. Since we have this secret, we will be able to create our own JSON tokens with a valid signature, and we will be able to present them to the resource server. If you have followed the previous module where we have used command line to create valid signatures, you should already know how you can use this secret to produce a valid signature using HS256. Alright, so that's all I have in my mind for this video. In the next video, we are going to discuss another class of attack called substitution attack. Welcome back. In this video, we are going to discuss an attack called substitution attack. Let's see how it works. I am switching to Burp Suite. Let's send this request to a new tab. And let's change the endpoint to v3 and click send. And if you see this, we have obtained a valid JSON Web Token. Let's copy it and paste it in Notepad. And let's copy the JWT headers and decode them using the online tool that we have used earlier. So I'm pasting it here and I'm copying the decoded text. And if you see this, RS256 is used to generate this token. Now let's also decode the payload using the same online tool. If you see, this is the payload we have gotten. It looks like this. Now what we want to do is we want to change the user ID to admin, and we want to change the algorithm to obviously none, but this becomes a signature stripping attack. It's not going to work against the URL /v3 because the JWT framework that I have used on /v3 endpoint doesn't support none type algorithm. So the only option now we have is to use RS256 or to use HS256. Now let's try to create a new token using these headers and this payload. But wait, HS256 requires a secret. We are going to use the public key as the secret in this case. We will have to use RSA public key as the secret key here, and we will have to produce a JSON Web Token. Usually the public key is not a secret. It should be publicly available to anyone. So with that assumption, let's try to create a new JSON Web Token by using these details. You can take this as an exercise and use the same command line techniques that I have shown earlier in the previous module to produce a valid JSON Web Token. But to make your life easy, I have created another PHP file on the server to do this for you. So let's access that page from Kali Linux. just remove this 256.php and hit enter. And if you see, a new token has been created. The algorithm that is used is HS256, and the key that is used here is the RSA public key. And if you see the payload, the user ID is set to admin, and this is what exactly we wanted. I'm going to load this hs.php on my host machine because my Burp Suite is running on the host machine, and I'll copy the token from there. Here it is. I'm currently on my host machine. Once again, I'm accessing the same page. Now I'm just copying this. You can see the user ID is set to admin. The algorithm used is HS256, and the public key is used to create this token. So I'm switching to my Burp Suite, and let's send this request to repeater, and let's type v3 and replace this token with what we have gotten from the hs.php page, and click send. And look at that, we managed to get administrator's credit card number once again. Now this attack may sound little confusing, so let's take a look at the source code to understand how this worked. I'm switching to the secure store server from Kali machine, and let's navigate to var www.html/v3, and once again let's begin with opening up api.php. When we are logging in, a token has been created using the private key and RS256 algorithm. Now let's take a look at a rest.php file. I'm looking for validate token function, and if you see this, the token is being validated using the public key, and the client can actually specify either of these algorithms. If RS256 is specified in the JWT headers, this public key is going to be used to verify the signature that is produced using the RSA private key. If HS256 is used, again the public key is going to be used to verify the signature. But if you remember, HS256 uses a shared secret. That means to create the payload as well as to verify the payload, it uses the same key. Since this public key is known to be public, we can simply use the same public key to create a new JSON Web Token and force the resource server to use HS256. So it will use the same public key to validate the token, and since it is created using the same public key, the token will be valid. And that's how the attack worked. So we are basically confusing the server that, hey, don't use RS256, please use HS256 and validate the token using this public key. If RS256 was used to validate it, it would definitely fail because the payload was supposed to be signed using a private key, and then a public key is going to be used for verification. But in case of HS256, both for creation as well as verification, the same public key is used. And that's how this attack worked. Welcome to another video. In this video, let's discuss how we can prevent all the attacks that we have discussed so far. The first one is none type algorithm. So we have seen that none algorithm is used so that we were able to tamper the payload and obtain the credit card details of admin. So none type algorithm is not used for security purposes. So do not use none type algorithm if you are using JWT for authorization. The next attack that we have seen was signature stripping. That attack worked because when decoding the payload, we have used an array of algorithms like this, HS256 and none. The client can specify which algorithm the server should use to validate the signature. So we forced the server to use none type signature, and we managed to obtain the credit card details of admin. To fix this, make sure that you are whitelisting the list of algorithms that you are expecting. Obviously, you are not expecting none type algorithm, so do not specify that in the array. However, there is another problem with the whitelisted array of algorithms. We will see that here with substitution attack defenses. The third one is cracking weak shared secrets. The fix is very simple here. We need to use strong shared secrets. The last one is substitution attacks. We have used a whitelist of algorithms, which is RS256 and HS256. Instead, we should only use RS256 in this case. If it is a business requirement that we should use both the algorithms to decode them, instead of using them in a single function, write two different functions for decoding RS-256 and HS-256 tokens separately. So you can actually invoke whichever method you want, and you can also control which keys to be used when using a specific algorithm. So these are some standard defenses that we can use to prevent the attacks that we have discussed so far. If you are watching this video, probably you have watched all the videos in the course. If you enjoyed this course, please leave a review and help us spreading a word about this course with your friends and colleagues. Thank you once again for choosing this course.